Hello guys, in this video I'm going to show how to solve count paths for a sum problem. So, given a binary tree and a number s, by all paths in the tree such that the sum of all the node values of each path equals s. Please note that the paths can start or end at any node, but all paths must follow direction from parent to child. Right. So for example, with this given binary tree and the target sum is 11, the question is how many paths that sum up to 11, right? A path can start or end at any node, right? So as you can see, with 11, the first path we can find here is 7 and 4, right? 7 plus 4 is 11, and it doesn't need to uh, start at the root node, right? Another path here is 1 and 10, which also sum up to 11, right? So two paths here, 11 and 4, and 1 and 10. So for this kind of problem where you have to define paths, then you can think of using a depth first search. It's going to be fit for this kind of problem. So because a path can start at any node, right? So and we want to keep track of we want to check the sum, right? We want to check the sum if it is equal to the target sum here. So let's see. So for let's traverse this binary tree from the root to leaf in depth first fashions, right? So because we need to uh, probably we need to keep track of the current path, right? So that we can check the so that we can find the path that is sum up to s, right? So the current path will be initially is an empty array. So we start the root node, so 12. We add 12 to here, right? So after visiting the root node, we will look at its child, which is 7 and 1. So we'll go for the left node first. 7. Okay. So as you can see, as we visiting one node, right? As we visiting one node, it could be the case that the new node will form a new path, right? We form a new path that sum up to S, right? So probably as we visit one node, we want to um, calculate all the paths that is all the path that ends at the current node, right? So for example, at the node 7, right? We visit node 7, so we want to check uh, all the paths that ends at 7. So there are two paths, right? Which is 12, 11, 12, 7, and 7 itself. Right? So, so that those are two paths that end at 7. So we will keep uh, visiting the child node here, which is 4. So with 4, how many nodes that ends how many nodes that ends at 4? There are there are 4. There are 3 nodes, right? 4 itself, 7, 4, and 12, 7, and 4, right? Okay, so it's clear that 7 and 4 will sum up to 11, right? So it is this path that we need. Okay, so after visiting 4, we cannot go down further, so we remove 4 here, and 7 we come back to 7, we cannot go to the right, so cannot go to the right, so we're done at 7, right? Pop 7 now. Okay, back to 12. We're done with the left side. Go to 1. So adding 1 to the current path means uh, it can form new paths, right? So the two paths here we need to check is 1 itself and 12 and 1, which is which will not sum up to 11, right? So we keep visiting from 1 to the left first, so 10 here. So adding 10, we will need to check all the paths that ends at 10. First is 10, which is which will not sum up to 11. Second one is 10 in 1, 1, 10, which is which sum up to 11. Right? So we will add it to the result, and of course 10, 1, and 12 will not sum up to 11. Okay, we're done with 10. 10 has no child, so come back to 1. So at 1 we're done with the left side. go to phi, which is a right child. So we will need to check three part, right? Which um, none of those part will sum up to 11, right? So we're done at 5. Come back to 1. At 1, we're done with left and right. So back to 12. So we're done with 12, right? So that is when we exit our traversal, right? So uh, okay, that's is enough for explanations. Let's dive in coding. Okay, so um, as you can see, our function takes in the root node, right, and the target sum. So we just want to use depth search using recursions, right? So probably we need to keep track of the current path. So the current path will be a parameter here, uh, and for the first call, it will be an empty array, right? So okay, we also need to keep track of the number of correct paths, right? The number of paths that sum up to 11, sum up to the target. So because it will be passed between a function call, so I will make it a object, right? So let's say count. It will be an object, and the current will be 0, right? So at the end, I will return count of current. Okay. So uh, as we visit the tree, as we traverse the tree, we we will like keep adding node to the current path, right? And check the the paths that end at the current node, right? And if it sum up to the target, we will increment the count by 1, right? So at the end, I'll return count dot current. Okay, so for each function call, our goal is to visit the current. Okay, so I'll do that by adding the value of kernel to the current path. So it would be current path of push root of bound. Right. Let's assume that the root is not known. So this one will valid operations. Okay, after visit the current node, right? I will check all the paths paths. Now check sums of all paths that ends at current node. Mm, So in order to solve, we will use a loop, right? So let's sum, current sum is 0, right? We want to start from the uh, end of the current path. So I'm gonna use a traditional for loop here with I equal to the last index, which is current path of length -1. Okay, and as long as I is greater than or equal to 0, I minus, we will keep adding, we'll keep adding the current value to the sum, current sum equal to current path at index I, right? So for each value that is added to current sum, we'll check the value of current sum. If it is equal to the target, then it's gonna be a valid path. So I will increment the count value by 1. Okay. Okay, so the next step is to keep visiting the child node of the current node, right? Traverse down the tree. So it's a binary tree, so I will have left and right child. So it will be root of left and root of right. So I only want to visit the child node if it is not null, right? So I will check. If child is not null, then wanna call the wanna visit the child node, right? By calling the function, because it passing in the child node with the next node we visit the target. It will be the same here, and current path, then the count. Okay. The last thing we need to handle here is probably uh, uh, is probably when we need to backcheck here, right? Because as we go down the tree, we will keep adding node value to the current path, right? So after I finish with the child here, right? Which means after this line, I probably want to backtrack. I want to pop the last value out of the current path. So current path dot pop here. So the last thing is to, if the we probably want to do, because here we check the child, check no for the child here, so it will be sure, we're pretty sure that inside the functions root will be not no, but for the first function call uh, we don't have this check. So to be safe, I will check if we don't have root here, return 0. Okay, so let's run the test to see if it works. Just 8 and 5. Oops, one failing test. Expected 3 but received 0. What is here? We only want to pop out of the current path if in the previous step we decided to visit the child. Okay, it works. So that is it for CalPaths for a sum. Thanks for watching. See you on the next one.